Okay, so if you're looking at this thing, right, these are cables, right? There's a cable there and a cable there. And you probably are thinking, gee, don't venture too far this way, because it's quite possible if this person walks all the way to that edge that you'd have to actually exert a downward force on this end, and cables aren't very good at pressing downward, right? So if this is your scaffold, this is why they attach the cables at the ends of the scaffold and not in the middle, because if you walked to the edge, it would flip. All right, okay, let's just solve this thing, right? We're going to figure out the forces. So there is a force here. Okay, there's a force here. And I'll call that T1, right? And that is at the left side of this beam. So I'm going to say 0 meters from the left side. I'm going to figure out everything from the left side because I'm going to torque about that left side, right? And then I've got the beam itself, the weight of the beam itself, right? So the weight of the beam itself is 112 times 9.81. So those G's are 9.81s, right? Okay, and then that's at, let's see, it's 12 meters long. It doesn't say it's a uniform beam, but I'm just going to say it is. So that's going to be halfway down. If this beam is 12 meters long, this will be at 6 meters. Okay, and then T2 is going to be a force up. I'm guessing, of course, that this is a bigger force because the person's standing right next to it, right? So I'm going to call that T2. And let's see. The second cable is attached 7 meters from the left side. So that's 7 meters, right? And then there is, the last force is the force of gravity on the person. And this is 72 times G. So 72 times 9.81. All those G's are 9.81s. Okay? And then that's at, and then notice that the person's standing 4 meters from the right side. But we want to know how far they are from the left side. We want to know this distance, right? Okay, so if this is 4 meters this way, right? If that's 4 meters and the whole thing is 12, then the person is at 8 meters. Okay, so let's just double check. We've got this unknown tension right at 0, right at the pivot point. I've got the beam, which is 112 times 9.81, and that's at 6 meters, right? And then I've got the T2, another cable lifting at 7 meters because it tells us 7 meters, right? And then I've got the weight of the person, and they are 4 from the right. If it's 12 long, they are 8 from the left side. Okay, we're ready to go. So let's set up our y equation. Okay, remember now with a y equation, we just, things that are up are positive, things that are down are negative. So T1 is, we hope, positive, right? Because it's a cable, and cables can't push down very easy. Okay, and then the next thing, I just go left to right. The next thing is the beam, so minus 112 times 9.81. All right, and then the next thing is the T2 is up, so plus T2. And the next thing is the weight of the person down. So minus 72 times 9.81, that's 0. So all the G's, they're 9.81s. I'm just trying to make it look all nice and neat like this. Okay. Now I can't use this formula yet because I don't know either T1 or T2. Either Ti1 or Ti2. Okay. Now let's use the red. Okay. This plus means up. This means down. Gravity is down, right? The tension here is up. By the way, you're in luck if you have the one with the 2 cables, right? You know they have to be an upward force, right? And then that minus sign is down. Just saying. All right. Let's go back to blue pen land, right? All right. So now let's set up our torque. We're torquing about the left side. So let's go torque about the left side. Sounds like a novel. Okay, the torque about the left side. So T1 is at 0. So 0 times T1. This is going to make this a single variable equation. Okay, and then we could argue about is that clockwise or anti-clockwise, but let's not. All right. The next one is the weight of the beam, and that's going to be clockwise. So I say it's plus 6 times 112 G. The next one is the cable 2, and that's going to be anti-clockwise, so therefore negative. So minus 7 T2, right? All these torques are RF, right? So I'm going R times F. Okay. The next one is the weight of the person, and that's going to be clockwise. This will tend to torque around, whoops, that's an X, a plus. Around this, it'll tend to torque it clockwise. So plus, and where are they at? 8 times 72G. Okay. And then that equals 0, I think. Let's just see. This force at 0, yes. The weight of the beam at 6, yes. The cable backwards, so it's anti-clockwise, right? This is anti-clockwise. And then clockwise is this person at 8 meters, right? So now let's solve this. Let's solve this for T2. T2 equals, hopefully we'll get the right answer here, right? Okay, so I'm going to go 6 times 112 times 9.81 times 8 times 72 times, whoops, gotta put a plus in there. It's 8 times 72 times 9.81. Okay, and then divide by 7. Whoops, no, I gotta get the answer first. Okay, now divide by 7. And I get 1748. So T2 is 1748.982 newtons. The fact that it's positive means that it's actually in the direction I predicted. Okay, so I would say that it's 1750 newtons up when the dust settles, right? But I'm going to use this number to figure stuff out. So now I'm going to plug it into this equation. All right, so let's bring this equation down here, right? So T1 we don't know. So T1 minus 112 times 9.81 plus T2, which is 1748.982. So plug it in, baby. T2, we're going to plug it in. Okay, minus 72 times G is 0, right? So I take this number, plug it in there for T2, solve for T1. Okay, so how do we do this? I guess I put this on the other side. So opposite of the thing I just got, plus 112 times 9.81 plus 72 times, I'm just doing calculator math here. And I get 56.057. Right, now the fact that it's positive means that it's up. Right, so 56.1 newtons up. At the end of the day, you're going to have to tell me for both of these forces, are they up or are they down? Okay, so do careful work, kids.